Okay. All right. So this book is a commercial book. Like I told you, there are the series of three: residential, commercial, industrial. And I believe personally they're one of the best written books about the wiring methods for residential, commercial, industrial. Granted, we're designers. It will walk you guys through how to wire a commercial building. And guess what we're doing in the commercial project? We're designing a commercial building. They have a blueprint for it, a sample blueprint for you guys. I always say when I was practicing electrical engineering, and I still say it, you can't have enough examples of projects. Every time you see a project, you learn something new. So here's a project right in front of you, designed for a multi-discipline or multi-tenant building, which is kind of unique. So I'll walk you through how they designed this project. So you pick ideas from them, and hopefully it will help us in the project that we're using, our own project. Does that make sense? Why we pick that one? Same thing for the residential guys. The residential book has a project with them, blueprints. I'll walk you through them next week, and it gives you an idea. They have kitchen, they have bathrooms, how to wire them, assemble right in front of you, how to do it. So when you design your own system, you can pick up these ideas. So that's the idea of using these books. Plus, it walks you through these two books, guys. Will walk you through the NEC code book with pictures and diagrams and all this good stuff. Make it easier to understand. So, good morning, my friend. The first chapter, guys, talk about commercial plans. There are 22 chapters in this book. It takes you from the plans. It walks you later on, guys. You're going to see a few of these chapters. Very simple. There are a couple of pages. They take one area of this project and they explain how they did it. So the chapters are directly related to the blueprints. Am I making sense? Chapters directly related to the blueprints. It walks you through how to design the system. So when they're talking about, for example, insurance office, remember there's an insurance office and they're doing it. So in this building, they have 5 tenants. It's a multi-tenant building, 5 commercial tenants in one building. And you have to design an electrical system for 5 tenants. The building, that's a unique. The building that we have, guys, it's only one tenant. The commercial building is only one tenant. Who cares? You don't have to worry about meters. If you have multiple tenants, what's the major concern? Consumption of power and charging. So you have to design services and bring the service and then put meters before you distribute the power to the different tenants. You can charge them if you're owning the building. The commercial building that we have, that you guys will be designing, is only one tenant. So do we have to worry about multiple meters? We only worry about 1 meter to meter the whole building. That's only really the only major difference. Okay, so let's see what we can do in terms of that one. We're going to continue to talk about the NEC book, like I said, understanding NEC book organization. You have the same diagram that we did in the commercial, so hopefully we keep hitting you guys with the organization of the NEC code book. Understand the process for updating the NEC code book. I can't update the NEC code book, and the NEC code book, guys, it is the Bible. You can hear it over and over and over again. So we keep kind of hammering you with that one. Basic safety rules. We talked about this one in the residential. We'll repeat some of the stuff that we did today too when it comes to the electrical equipment. Project requirement from contract documentation. We'll talk a little bit about the contract documentation, the clause and the specification, the blueprints. When you have a project, guys, the project is made out of 2 things. Blueprints, here's the blueprints, right? And then a set of specification, including the contract and the documentation of everything they need to do in this project. So we'll talk about these. Application of building plans and specification. Of course, like we said, we'll talk about the plans and specification. How do you locate specific information in the plans? Now we're not looking at me and say, well, I'm the one who designed the plans. But guess what? You need to go put a lighting fixture right next to the door. Don't you think that you should know what the height of the building when you put perimeter lights? So where would you get the height of the building? From the architectural drawing. So these are the first 6 pages here are architectural drawing. So you should be able to walk through these architectural drawings and pick information from them electronically or from a hard copy. Am I making sense? because you need to put receptacles on the countertop. Well, you need to know what the height of the countertop is, right? So you need a lot of information that we need from the blueprints that are not electrical, because we create the electrical. And then industry-related organization, guys, unreal. I mean, like I said, 20 some years in the industry, and I still discover, my God, it's just. I was reading an article about swimming pool bonding and grounding. About two kids got electrocuted in a swimming pool, and then I thought I know about swimming pools. It's unreal when you read all these stories. International Association of Electrical Inspectors, but really magazine, and it emphasizes what you know and it teaches you. So my point is, you guys you're going to be learning all your life in this field. And don't forget there will be the international unit system. We'll touch on that one again, one more time. So introduction. So we'll talk about this will be safety, the wiring methods, electrical equipment, luminaires, all these stuff, guys, will be covered in the secret book as well as in some of the chapters that we're going to be doing. The text and the set of the blueprints and the specification, guys, and that secret book will be used through the whole book when we're doing it. You're learning to commercial installation. So the whole idea is how do you design a commercial project and pick the ideas that they use. Like, for example, I always tell the people, when we do lighting for our project, guys, I give you lighting fixtures. Those guys have a different type of lighting fixtures for different applications. Insurance company. We don't have an insurance company commercial building, but here's an example for how do you do if you have an insurance office and they want you to design a lighting system for an insurance office and receptacle. So here's a sample for you. Does that make sense? Blueprint. Here's a template for you. Because the one that we have is an office building. It's not an insurance office building. Drugstore. There's a drugstore here. How do you design a power system for a drugstore? I mean, with receptacle and light. Well, here's a blueprint for you. So these are what blueprints that you can use. Okay, we talked about this one, guys, this week. And I emphasize the word electrical. Electricity is dangerous. You can be blown up. You can be electrocuted. So take it serious. And you are designers. First, you are not licensed, bonded, or insured to do the work. And while you are working with licensed, bonded, and insured, you should keep your distance. NFPA 70E suggests the distance, if somebody's working on this panel energized, the safest distance away from that panel is typically assumed to be 10 feet away from the panel. So if the panel is open, make sure you're at least 10 feet. That will clear you from any or almost any arc flash. Unless you know otherwise, it's 10 feet. So somebody opening a panel and you're on the side, make sure you're at least 10 feet. So we will clear most of the arc flash boundaries. OSHA, of course, is the one that enforces all this and defines you. We talked about OSHA, guys. Occupational Safety and Health Act. We have OSHA Minnesota, the OSHA Federals. Those are the guys who find you and enforce the safety rules when it comes to working in the electrical industry. We talked about any secret book, guys. I define a qualified person. You guys remember that one? Somebody like you have skills and knowledge. That's you, then have received safety training. Skills, knowledge in the related topic. So if you're doing lighting, you have to have skills and knowledge in the lighting. If you're doing power, you have to have skills and knowledge in the power. And have received training to recognize and avoid the hazard. So what's the hazard coming out of changing the ballast? Recognize the hots, which one is hot, which one is not hot. And what happened if you short that panel? And have received safety training, how to recognize them. So that's how define qualified person. I always tell the people I'm a master electrician. If I go to a nuclear plant, powering system, I'm not qualified. I've never worked in a system like this. You can see that qualification goes with you have the skills and knowledge and safety training. I don't know what happened if there's a nuclear spill in that area. I don't have safety training on that particular topic. Or chemical plant. If there's a chemical plant working electrical system, a chemical plant, you have to safety training and what happened if you have a chemical spill that could affect the electrical equipment. So big deal. 70E, guys, is the Bible when it comes to working on electrical equipment, working on electrical equipment energized. When you become a project manager, you're going to do training for your own electricians and your personnel on 70E. Hunt, where's Hunt guy? Hunt, they have safety trainer, a coordinator, very nice gentleman, coordinate all their safety training. So because why do we think people care? It is the law. When it comes to OSHA, becomes a law. You basically they can't drive you out of business if you don't do that. They'll shut you down if you don't care about people's life, which a lot of us do. But it,
We also get better insurance rates if they have
incentives, I'm sure. Yeah, training. It's like everything else. Training, incentives, and so forth. A part of the safety training, guys, when you have portable tools, and we talked about this one, power tools and what's not, they have to be plugged into GFCI. We all know that. In a construction site, anywhere, portable tools. Safety related to the arc flash as well as arc flash. Arc flash is a big ball of fire. Arc blast is all these melted cover that runs at you as effect of the rate of arc heat. We talked about this temperature, guys. 35,000. Imagine 35,000 degree Fahrenheit going into the cover. It melts the cover, melts the aluminum, and it pushes it. So it becomes bullets, basically. You have a melted cover aluminum running at 60, 70 miles an hour at you. So you can see why people don't survive.
that's worse than bullets because IEDs were made out of copper and they would turn to molten copper and that's what penetrated through the armor of all the U.S. guys.
Wow.
So
That's
yeah,
yeah.
that tried to go right through you.
Yeah, yeah. If it goes through the armor, she'll go definitely. That's why a lot of people, guys, you might survive the arc flash, the heat, but the melted cover will kill you. So it's a big deal. That's why speaking of which, that's why they don't go more than higher than 40 um, calories. They charge them in calories, so they don't go higher than 40 calories. Not because they can't protect you from heat. Like the firefighters have higher than 40, but they don't have an explosion for the most part. They don't have cover melting. So OSHA and 70E don't qualify these PPE, the personal protective gear that they put on them. They stop at 40, not because of the heat, because they can't. They have equipment for the heat, but they don't have equipment for that melted copper. So you'll not survive the blast. Basically, the flash is okay. You can go higher than 40, but the blast you can't. So anyway, melted copper and aluminum, everything guys, the most important, instantly melting, running at you. Um, so you can't get worse than that. So we'll blow hot metal particles and hot gases all over. So that's where I can't emphasize enough, guys. You're designers, you're not electricians. If you go when you go to the airport to get some pictures, whatever, the electrician is opening things. Keep 10 feet. I know some when they, especially when they're working on it. So at one point you have to get in there and take some pictures. If you guys modify things, you have to go there and get some pictures. Make sure you get in there. Technically, you should put your PPE when you approach that boundary. They call it the arc flash boundary. You get into the arc flash boundary, you have to put your PPE. It's not enforced a lot on the engineers, or it's not. Please, it's not practiced a lot. Or give the electricians, while he's putting his PPE, the camera to take a couple of pictures from the inside of the switchgear, if you're not putting it in. And don't think that small mans will not get you an arc flash. They could get you enough arc flash to burn your eyes. Yeah, you didn't die, but you lost the vision in one eye. So smaller services, guys, could be also lethal. This is just your portable plugs that you are supposed to use in construction sites with GFCI protection. The arc flash labels that you're supposed to have. This is required on every panel. You guys are going to be generating these with me for the projects that you're going to do. It warns the people that before you open this panel, this one should have one. Before you open this panel, make sure you put the proper PPE. 70E require you to put the category 0 through 4 also. So is it category 0? Like I'm dressed up right now with the glasses probably and gloves. Category 4 is you've seen him like a big suit and shield and everything else, like coming from the space. And the in between these two. A couple of hints. You guys not electricians, but again, you will be with electricians in the field. They always tell you guys don't stand right in front of the switch gear. Anybody knows why? You have a panel. The panel is right. It's they call it a box, right? What happens if you have an explosion in the box? The explosion, you probably remember the explosion. The explosion, when you have an explosion in the boxed area, it will go to the easiest the easiest side. The easiest side is where the panel is open, right? If you have an explosion right up in the air, it goes all over. If you have an explosion in the box, that's even worse because it channels the whole energy right into the open area, which is your chest is standing right there. You know what I mean? That's why if the panel is there, they always say stand to the side because the energy channels right here. Your chances of surviving is higher. So that's why you see a lot of electrician guys when they open the switch. Here's the switch. They don't stand right and open it this way. They go this way and they open it, to the side. So there's an explosion. It will your chance of surviving is higher. So a couple of tricks, guys, for that one. More information about all this hazard, guys, as you move on. And see, as well as 70 will give you tons and tons of info about the electrical safety, which you probably, if you're a project manager, you'll be very aware of that. Okay, moving into the contract, away from the safety. So if you guys you can follow up with the book too and look at the contracts that we do. Commercial building specification. When a contract is awarded, plans and specification. So when you get the contract, you're going to have part of it, your plans and specification. We'll be talking about this all the time. When I was at our Beckett, the electrical guys, the electrical spec is 2 4-inch binders, just the electrical. Now add to this the mechanical, the structural, right? The environmental, the architectural, all the other disciplines, and you can see how it gets out of control. These are specifications. The general specification. So specification, most of engineering firms, guys, they have one individual specialized in specification. Just his job, his or her job, especially multidiscipline. Like if you have the architects and engineers in one guy specialized, just keep an eye on all these specifications. That's his job or her job. It gets out of control. Typically the first section, there is general clause. One section is called general clause and conditions. These are not electrical guys. Remember, they are our electrical spec. There's an entity called CSI, Construction Specification Institute. This is not CSI Miami. You guys watch CSI? Or CSI New York? Which one are we missing? There's like CSI Las Vegas now? Is that new? The newest one? Horatio. So, so CSI. Those gentlemen, I'll give you guys, as we go to the spec, I will give you a list of how they label. It's a book. Just the numbers of the specification for all the disciplines is a book. The numbers of the specification for all the disciplines is a book. It's close to an inch book. Just the numbers, just the number of them. So CSI specification, guys, start with, for us, it's right now 26,000, 1, 2, 3. So every specification that starts with 26, and then they give you, that will give you what? Almost 1,000 specs, 1,000 spec electrical, 00001 all the way to 1,000. So they give the electrical guys and gals 1,000 specifications. So one spec for the lights, here's one spec for the receptacle, the devices, they call them, here's another. One spec for the wiring methods, here's a third. So, and they're all, most of them are used, guys. So whenever you see CSI specification 2600, when you guys are reading through a spec, you see 2600 spec, that's us. So be aware. Other disciplines are 27 and 25 and what's not. Okay, the general, I can't remember the number for the general. So, but start with the general clause and conditions. The first section, they have legal requirements for the project. So who's doing what, when, and where, and what's need to be done in that general requirements, and who's liable for what. So they have a whole, that section we typically is that's big specialized guys responsible for that section. Editor. That's the one they give to your lawyer when you get sued. The contract and what's not. And then they have index to the sections. Then we have an takes to all the section, it will give you 26, big 26 is electrical. I can't remember, was it 27, I think is mechanical. And they go through all these, and they're 1,000. When I say 26, they're 26,000. Start with that. They give you a list of all the specification. Then also they have looks to the bidders. When is the bidding opening is going to be? Part of that clause and conditions. Schedules of the drawings for each discipline. The proposal, the agreement, and some general conditions. These are, you find them in general clause and condition. If you've never seen them, you probably wouldn't see them unless you're a project manager. And if you're a multidiscipline company, you refer them to your specialized CSI guy, who read through them, and the lawyer reads through them, make sure that they're good to win a lawsuit. Any comments, guys? Any questions about this? And that's a big section from the specification. You probably will not, guys, get into it unless you are, like I said, the project manager. Then they have supplemental general condition, more specific than the general. And disciplines and whatnot. And the last one is the contractor. This is the most important one. This is our 2600 CSI specification. These are ours. And so you have 26 for us, I think 27 for mechanical, I'm going out of memory here, and a bunch of other specifications. So these are the disciplines that you have to pay attention to: the electrical, the general contractor, and plumbing, and the electrical, and environmental, and all this good stuff. So you'll hear, where's a Hunt guy? He's not here yet. But at Hunt and Parsons, guys, when they do bid a job, they get all these specifications. The electrical ones, they go through them thoroughly. But the mechanical ones, especially, you know what they do? They put them in they take them in a Word format, and they do search on them. So they go to the mechanical contractor, and they search. They search disconnects, certain words, and they go see, where does the disconnect? Are we liable for disconnects, or the mechanical liable for disconnect? It will send us back. So they search certain words, because you can't read all the mechanical spec and the electrical. There's nowhere there. So they use search function on a lot of these documents to identify controller, disconnect, certain words that they use that they have seen over the years, the mechanical use, and they're not sure if they're liable for it. They search it in the specification. So that's your specification. Then you move into, and feel free to read them, the clause and what's not, guys. Then you move into the drawings. The drawings, you guys are very, very familiar with them. The blueprints, the E's. There's the E's for the electrical, M for mechanical, S, I believe, for structural, A, and this one A for architectural. And then when they label them, Gary, they label them by first the letter and then the number. So if I want a sheet 1, it will be E1, E electrical 1. If it's mechanical, it will be what? M1. If it's structural, S1. That's easier for all of you if you're working in an engineering firm. So when you see S1, that's structural. Maybe you shouldn't pay a whole lot of attention to it. A1, that's architectural. How about A55? Also, anything A is architectural. And multiple other disciplines. These come to one. Any comments, guys, about labeling them? And then they put the numbers. And the numbers are typically 0, 0. So, for example, start with E00 all the way to typically E99. So they go E00 to E99. E01, 02, 10, 12, 13, 14, all the way to 99. You can go as high as you can, but typically 2 digits. Any comments, guys? Any questions about the drawings?
What's the money sign?
The what?
The money sign?
The money sign, that one that's a switch.
That's a switch.
Yeah. The dollar, yeah. We'll talk about symbols, guys, in a second here. The dollar value is the switch. There are blueprints that you have, the symbols that you have to do. Then also BIM, they added BIM. You're going to hear this one, guys, all the time. Building information modeling. That's what you're doing with your friend Chad in the commercial project. You're doing 3D design. So you take it to Navis, or you take it to other softwares, guys, and they can interface it with machines that can cut conduits even. And they can interface it with other disciplines that do collagen detection. So if the HVAC fixture is sitting right at the top on the same place where my lining is, and when you do collagen detection, it will tell you, hey, you might have to go consider there's a conflict between these two disciplines in this location. So it's a big deal when it works good. So that's your BIM. 3D, like I said, the third dimension is the major part of the BIM, building of, you're going to hear it all the time, building information modeling. And it's not just a third dimension though. BIM is an intelligent device, guys. For example, I told you if you click on the knob of the door, it will tell you who the manufacturer is, what size, and what's the price even. If you put this information, if you click on this fixture, when you put it in the system, it will tell you what the ballast, what the voltage, what the watt, what the price, what the connection, all the information that you need about this fixture. Any comments, guys, about what the BIM is? BIM, Building Information Modeling. So there's a lot of information in a 3D format. Does that make sense? So it's supposed to be, guys, the BIM, when it's done, and you give it to the owner, the whole model. The owner is supposed to click on the wall, and it will tell you all the characteristics of the wall. So if you want to change something in the wall, you pull this information by clicking on the wall. And it gives you all the dimension, tell you how to patch that wall, what material you need for this wall or ceiling. And same thing, click on that fixture, will tell you what the bulb size, what the ballast is. So when you change it, you have all this information available for you. So the whole idea is real-world visualization of all the project. Any comments, guys, about BIM? BIM is what you're doing with your friend Chad. Big deal. Your plans and specification have to be submitted for the most part to the local government, guys. So when you do a hospital or a commercial building, you submit it to the city typically the city or the state or the county, and their city engineer, state or county engineer will review it, approve it or not approve it or modify it for you. So most of public work and most of public buildings are required approval. There's also a dictionary construction. If you guys go there, they will give you terms found in the construction dictionary of construction terms, the terminology that they use. So cities and power companies also can enforce and develop their own code. So you're going to say, like I believe in Chicago, you can't use Romex. You have the city of Chicago required to use EMT when you're wiring residential. So not just because you know the anti-secret book, in Minnesota you're safe. Because most of the time we adopt anti-secret book as is, we don't modify a whole lot. You go to other places of the country, either they don't adopt it, or they add to it, like in California. So when you become a big project manager and go work in California, make sure you be familiar with their code. The first thing you do, guys, is you contact the state or the city, typically the city that you're in. Ask them what type of electrical code are they enforcing. Are they enforcing the NDC code book only, with modification? What else should I know? You come to Bloomington, for example, or my city, and when you do lighting outside, my God, they drill you. Have you anybody done lighting outside parking lot in Bloomington? Yeah, the inspector will come with a lighting meter and literally measure it. And if it doesn't achieve the requirement that they have, they don't want lighting spill because the neighbors complain. They will make you redesign the place. So it's a big deal. And you are to submit the outside lighting to the city of Bloomington. They have to approve it for you before you do it. And when it's done, they go measure it too. So they have one of the strictest, my understanding, lighting code in the state. While other cities, you go work on them, and they don't care. What do you care about lighting? Oh, we don't care. Just make sure it's not annoying. So. Outdoor light. Yep. It's the trend. Yeah. Yeah. It's the push now. The LED is the push. Meters and measuring it. Measuring, absolutely. Make sure you guys pay attention to the latest NDC code book, which is published by the NFA, of course, which is their goal is to protect the people and the property from the hazard of fire. This is just a few organizations that you should be aware of, guys. You can't call yourself electrical professional if you don't know it. The first one is the Bible. You guys are familiar with that. We talked about it. Literally, a lot of people consider the Bible with electricians, NDC code book. If you're in an electrical field and your NDC code book has never been opened, sits on your desk, oh, there's a problem there. You haven't read the Bible. um, NDC must be consulted before when you do anything. The NDC guys will give you the design and installation requirement. So that's why if you're designing, you need to know it. If you're installing, you also need to know. So, who writes it? Of course, you guys, the public writes it. If you guys know how the NDC is ran, you do proposal. So anyone can submit proposal. They review these proposals, and they either accept or reject the proposals based on the committees. They have committees, 19 committees, I believe. They accept the proposal based on the merit of the proposal. For example, I would like to make a proposal that all lighting fixtures have a GFCI protection on them. Lighting fixture. You submit it, you look at it and say, what's your justification for that? You have to justify. If you have good justification, well, 15 people have been killed in this state because of doing this and that, and you have to justify it. And if you justify it, passes the proposals. Then they have comments. Then they put it to the public. Here's what we're going to do, guys. We're going to put GFCI on the fixtures. All fixtures have to have GFCI protection now. Then on the stage of comments, all interested parties and you and the public will review the comments, comment on it. So maybe we're crazy. So they put it again for comments, review the comments. If it passes the comments and everything is okay, then it goes for voting. And with the vote on that, if it gets the, I think it's 2/3 or whatever, it becomes the code. And that's how they build the NDC code book from all of us. It's really interesting to see all these people. They are changing them. We used to say code making, these are code making panels. There's, I believe, 19 of them. Then it goes from the proposal and reviewing it into the comments, the comment stage, and then the last stage, of course, it goes into the voting where they adopt it and it becomes the NDC code book. And they publish it. Then it goes to Minnesota, for example. Then the legislatures get a piece of paper, or not a piece of paper, a document from the Department of Labor and Industry in our state by the electrical unit. The electrical unit, through the lawyers in the department, they submit to the legislatures a proposal, whatever they call them, to adopt the NDC code book. Then it goes to the legislatures. Do you think those guys in the legislatures know what this book is? They don't. They depend on the experts in the field. The experts are in the Department of Labor and Industry right now, our electrical expert. They say, yeah, we want to adopt this one. The legislators say, oh, it's part of the laws and rules for this year. We're going to stamp it. And they approve it. It becomes a law. So, and this is not just the only law. The plumbing law. You have a question?
So these come out every 3 years, right?
Every 3 years.
Can they change the code after they release it after 1 year? Did they send something out? Or
Yes.
Go into the next?
Oh my God, now you open a can of worms. After they publish it, they have two things that you have to pay attention to after it's published. By the way, this book right now has, I counted, 85 errors in it. But they're human beings. So after they publish it, you're supposed to go to the site and there's erratas, if I spell it right, erratas. They have the list, if you go to the website, they have 3, you can charge them, I have them all. Erratas. These are the mistakes that they did when they published the book. So, and like I said, there's close to almost 100 mistakes in the book they have in front of you right now. I'll be pointing things related to us. That's number one. So you have to pay attention to that. Number 2, there's tentative interim amendment. TI, tentative interim amendment. After they publish it, some expert in California looked at it and said, you dummies, what have you done? You forgot that. They submit this after they publish it. They contacted them, and that gentleman knows what he's doing. He owns a company, whatever, meat and knowledge. Oh my God, we screwed up here, because it's made by people, So then we have to correct it because we didn't pay attention to that. So they add something called tentative interim amendment. And that becomes part of the NDC code book. So when in Minnesota, when we adopt it, We adopt this as well as the erratus that comes with it and the tentative interim amendment. And right now there's, I think there's 4 tentative interim amendments for this book. It keeps people like Chad busy with all this good stuff. So it's, but for the most part, these are, remember, these are only the 3% depth. All this erratus and tentative interim, it's only the 3%. The 97% is solid. When you get the book, you get the 97%. So. Okay, we talked about the arrangement of the sequence book. The same picture as that we did in the first 3 chapters apply to every installation. These are supplement the 1 through 4 through special occupancy, equipment, or condition. And chapter 8 is communication, related to communication, and applies only as reference. And the tables are applicable as reference, and information annexes are FYI only. Any comments, guys? Any questions? I can't believe, you know, this is the second time you're going to go see the same arrangement of the sequence book. So languages and conventions, they will use, guys, the word, they have a whole book about how to write any sequence book, a book, how to write and how it's written. In terms, we talked about sections, guys, we talked about articles and sections and paragraphs and exception and what's not. So it has to be written in a certain way. And there's languages that contain shall, for example, you have to do it. Shall not, you can't do it. Shall be permitted, it's up to you. For example, a dedicated circuit in a kitchen for the refrigerator. If you guys go there, it says, it shall be permitted to put your fridge on a dedicated circuit. Well, I don't want to do it. It's okay. Shall, you have to do it. Shall not, you can't do it. Shall be permitted. It's up to you. So these are the language that they use. There's also exception that you have to pay into and citing code references. Every time you have, I don't like it. You don't want to butt heads with electrical inspectors, guys. But if your chances of winning a disagreement with an inspector is much, much, much higher if you can cite any sequence book. So they want you to put GFCI on this wall. If you go cite that or ask the inspector to tell you, educate you and tell you, where does it say that a receptacle in a room and education will need a GFCI? That will be much higher. I mean, if it doesn't say it, why are you enforcing it? Remember, the authority having jurisdiction, we talked about something called authority having jurisdiction. This is the fancy name that we use for electrical inspector. Authority, because you can enforce things, but you have on what? On a geographic area. So if I'm the inspector of Bloomington, I can't go to Richfield and inspect. That's where the jurisdiction is. You have to have the authority and a jurisdiction. A couple of terms that you guys have must know. Approved, accept. When things are approved, they have to be accepted to the accepted by the authority. So if I say something is approved, accepted to the authority having jurisdiction, that becomes approved. Authority having jurisdiction, authority having jurisdiction. The authority having jurisdiction in your class is Chad. I'm the authority and having jurisdiction here. But in the other class, I always tell the people, when I train people, I say, I'm the authority having jurisdiction, meaning if I tell you something wrong, unless you prove me, it's going to be right? That's what the inspector is. They're the law. Authority having jurisdiction. People, typically electrical inspector, equipment must be listed. Guys, we talked about listing and labeling. They go test them, they put them on a list, and they put a stamp on them with a label, meaning this piece of equipment it will do exactly what the manufacturer tells you to do. And identified as applied to equipment. And also they have the word identified. So for example, this picture is not identified for wet location. It's dry location, listed for dry location. Can I take this picture that's listed for dry location and put it outside? No, why? Because the code says listed and labeled equipment must be used according to the listing and labeling. This is dry. Can you put it in wet? No. So, so we talked about the product, guys, the third party. This is a term that you guys want to know all the time. National Recognized Testing Laboratory. Those are the guys who take equipment, third party, test them to verify that what you're saying is right? You can't test your own equipment and we believe you. So The notoriously famous one of them is, of course, the UL, and there's the Canadian standards too, and a bunch of others. And can you guys see the word courts and must rely on them? So it becomes a big deal. If you can't have a UL listing for equipment in the U.S., you can't sell it. It's illegal to sell it. Nobody no inspector will allow it, unless you have an alternative. There's other alternatives, but if you don't have listed equipment by either UL or other parties, your chances of staying in business in the U.S. is nil. UL guys, they have laboratories, and when they investigate materials, devices, product, equipment, construct materials, and systems to define any hazards. So I always say, guys, here's a switch gear. This is a 4,000 amp switch gear. It's going to be interrupting 85,000 kilo amp. So here's, and the voltage is 480/277 as high volt. And you design it. You send it to UL. Here's this is the 4,000 amp switch gear, the circuit breaker right there. And you think, and you want them to test that circuit breaker for the switch gear that can handle 85,000 amps. So they have a machine, they literally inject 85,000 amps into it, and it's supposed to handle it for 30 cycles. 30 cycles, guys, is 30 over 60 equal 1/2 of a second. A half of a second. Supposed to handle it for half a second. Just half a second. That's what the listing is. So they sit there and watch it for half a second through equipment. After half a second, if it blows up, that's okay. We only need half a second. If we handle it for half a second, it gets the UL approval as ANSI standard.
These are ones, that's what I did at my work in the summer.
Did you?
They put electronic units, you can actually change the time it takes until it goes.
Yep. Yeah, absolutely. You can delay it. Delay. Absolutely. If you can look, we'll talk about these guys when we go commercial. Yeah, there's a lot of adjustment in it. Absolutely. A couple of others, guys, I'm not going to go into details with them. Here's the ITS. The Canadians do the same thing. Counterfeit equipment, counterfeit product is a big deal because they're not tested or labeled, and they can hurt people in life. So that's why the whole idea, guys, because we want to minimize the amount of counterfeit equipment. So you'll find a UL label, counterfeit UL label. Chinese will make anything you want. Or anybody else. So they have a white book. Remember we talked about that white book. If you're in doubt, you can go check with the white book and call the rep for the UL. The UL's rep. NEMA also another one, guys. They develop standards for equipment and NEMA gear and NEMA disconnects and all this good stuff. ANSI is a big deal. American National Standard. They partner with other institutions to develop other standards. So you have something called ANSI switchgear. This is an ANSI. This can be in an ANSI switchgear. That's as fancy as you can get in terms of switchgears. What is the switchgear? A switchgear is a refrigerator-sized panel. Think of the largest refrigerator you can think of. That's, I don't know if you guys have seen them. They're somewhere in there. That's the largest refrigerator. That's only one section of a switchgear. International Association of Electrical Inspectors, those guys specialize in inspectors. So they interpret things and they share the information among each other, guys. Why do you need to pay attention to them? Because you know who's going to be the inspector that's going to inspect your job. Most likely they're going to be listening to IAEI. So if there's something controversial in the inspection or in the code, most likely your inspector in your area have heard about it through IAEI. So if you're a member of that, guess what? You heard about it and you know how to solve this problem. So the last thing I want to talk about, guys, is this one, which is so important. Illumination Engineering Society of North America. This is called IES-NA of North America. Those guys are specialized in the lighting science. They put seminars, they put books about lighting. You gentlemen are going to be learning from your friend Chad using visual how to do lighting calculations. So they specialize completely in lighting. When you graduate from here, guys, you can be a lighting designer. You design a system and you stamp it with your lighting designer, certified lighting designer. I think Halberg, the lady who works for you guys, that lighting lady, Lisa, will be coming here, I believe, to talk she's a certified lighting designer, works for Michelle Cooley Erickson, and she will come here and talk about the advantage of being a licensed certified lighting designer. So big deal. ASHRAE. ASHRAE is a big deal, guys. We hear people talk about ASHRAE. ASHRAE, every time you hear ASHRAE for us, remember energy code. ASHRAE energy code. ASHRAE energy code. That's what ASHRAE is. Like IES light, ASHRAE is energy code. Those guys are a bunch of mechanical engineers nationwide. And it's American Society of Heating, Refrigeration, and Air Conditioning. And they put the standards for the heating, air conditioning. And guess what? That part of it is the energy code. The energy code is a big deal driven by them. So why would they drive? Because if you want to heat this building, think about it. If you want to heat and cool this building, which is a major chunk, don't you think you need to worry about how much heat is coming out of this fixture? You should. How about how much heat is coming through this wall and these windows? So those guys, because they're heating and cooling a building, they take into consideration the heat coming out of your body when they do their heat calculation. They take how many people in the room and they count how many heat is going to be radiated out of your body in the whole heat, so you can cool it, right? And the windows. So anyway, so they drive the energy, guys. They drive the whole energy. So you're going to hear about them all the time. And those guys, National Electrical Installation Standards, they'll give you NEIS, for example, installing EMP conduit. I can install EMP conduit in any way, shape, or form. They have a whole book about the best practices. Have you guys used them when you were at Dakota? We have them here in our program. We have a list of, oh my God, a lot of books about rigid metal conduit. How do you thread and bend a rigid metal conduit? The best practices in the industry. So they write books about the actual installation of these equipment. Who cares for you guys being designers? You're going to be a project manager. You're going to be a project manager at Hunt, right? Those guys are bending conduits, and you see a sloppy job that doing. Well, that would be a good. Maybe you should train on that little booklet that says, "Here's the best practice how to bend conduits and install rigid metal conduit." So they're really cool books that they have. Finally, Mr. PE. Mr. PE, I'm a PE, registered engineer. In the state of Minnesota, as well as in other state, guys, there's registration for electrical engineers. To be a registered engineer, you need the following. Typically, in most of the states, you need to have graduated from a four-year electrical engineering program. Four-year electrical engineering program. That's step number one. Step number two here in Minnesota, you need 4 years experience in the field, and then you need to pass fundamental exam, and then you need to pass professional engineering exam. These are 8 hours, and this is 8 hours. That's how they do it in Minnesota. 4 requirements. You have to graduate from an accredited, ABIT accredited engineering college, full engineer, electrical, bachelor of electrical engineering, 4 years in the field, electrical fundamentals, exam 8 hours, electrical professional engineering 8 hours, then you get you a PE. What does a PE allow you? Allow you to think to sign on any drawing for any system, for any city in Minnesota, for me. If I go to Wisconsin, guess what? I have to register in Wisconsin. Here's the good news is, I don't have to retest again. I have to submit paper for the city of Wisconsin or North Dakota, the state of Wisconsin, any other state. You submit your paper and you get your registration. You pay your dues, of course.
Did you get your Wisconsin license? Don't you practice here now?
No, I don't. I'm not aware of any reciprocity. Yeah, yeah. It's you have to be licensed in the state that the work is in. Like a lot of engineers guys will see like a guy and bunch of for you guys. There's some engineers that are registered in 50 states. 50 states, literally. They carry registration 50 states, and each state have different. Like my license every 2 years, I have to renew my license in Minnesota, so I have to go to 24-hour training. 24-hour training to renew my license, and I pay $200 and I think close to $300 every 2 years to keep my license. Now imagine 50 states times 50. If you have 50 states, You guys, Hunt has a bunch of people registered all over the country.
Yeah, but their checkbooks are
Yeah.
pretty full. It's not.
But, and not just checkbooks, the companies, guys, what they do, yeah, the company, if they want me to register, here's how the practice in the industry. The practice is you pay for your own state. So if I'm working at Mishrat Cooley, I will pay for Minnesota. If they want me to register in Iowa, they will pay for any other state other than my home state. That's the practice. You pay for your home state because that's your baby, and then any other state you have to pay for it. So that's what allows you to sign off on any project, and your signature is approved almost, I would say, in every city and state if you're licensed in that state too. And it allows you also to test equipment and write a report if there's a switchgear coming from China and to Minnesota to be installed and it's not UL listed. They come to somebody like myself and register. You have to first register with the state. I am not registered with the state to do this type of work, but if I am to register, then they come to me and say, Chad, write us a report about this piece of equipment. So they fly you all the way to China, go meet with their engineers, and dine and wine with them, and write a report, see what the testing that they did, witness all their tests as a third party. You write a report, submit it to the authority in Bloomington, and they say, yep, now we trust that this piece of equipment is okay. And they do it all the time here, guys, for foreign equipment, all the time. If you go to the Department of Labor and Industry, you'll find name a bunch of people who are registered to do this type of work. Yes, sir.
One of us want to become an engineer. Do these 2 years count towards that? Or do you have to take a whole nother?
General. They count as general. So you need to take, if you're going to be a full engineer, you will probably have to take another at least 3 years. Yeah. I only have, in my 12 years at Dunwoody, gentlemen, in my 12 years at Dunwoody, I only have one student made it. I had 5 tried, 1 made it. Because it's just tough. Go to engineering, yeah. Go back and the one guy. So, okay. Moving on, away from the engineering. Abandoned cables. The IEC code book guys require you, though some specifications are not clear about it. If you have abandoned cables, especially fire alarm security phone and data, what do you need to do with abandoned cable? Remove them. So you put it in your specification as the electrical contractor must remove all abandoned cables. Why? Because if there's a fire, they don't initiate the fire, but they will contribute to the spread of the fire. So these you'll see all the time. Finally, guys, the SI system. We talked about the SI system the other day. Manufacturers, a lot of manufacturers have both the metric and the standard systems in their product. The NEC code book lists the metric and the standard. So if you're working in the Middle East on a project, or working in South America or in Europe, you should be able to use our NEC and structure code to design a system for any, like in the Middle East, a lot of countries accept NEC design. In Europe, you gotta be careful. South America, they accept it, and they design a system. I mean, we were at Elizabeth Beckett and we designed a huge project for United Arab Emirates. Big, they kept us busy for a while. A huge project with chillers and all this stuff. It's all based on NEC and the metric part.
Is that country that's drilling a whole bunch of oil and they're trying to make a Vegas for the world or something like that?
Dubai, right? Yeah, yeah. It's a part of the United Arab Emirates, I think. Yeah.
I bet you can work there and make a bunch of money.
Yeah. Okay, metric. We talked about these guys, the metric conversion. For you guys, I told you that conversion software that I gave you will get you all the conversion between all these. Student.
Is it on the laptop?
It's not on the laptop. You made shortcut. Yeah, you can drag and drop it into your. It's in the student favorite online. Instructor student favorite. Trade, we talked about yesterday, guys, or the day before, about the trade size versus the interior diameter. We said trade size is just a word to know half an inch. Rigid EMT, they will be different, so be aware of that. The trade size. Designator raceways. So here's your standard raceway sizes. I've never seen anybody refer to the raceways in this terminology anyway. But be aware that a half an inch is equivalent to 16 millimeters. So Guide to the metric. I'm not going to talk to you too much about the metric. The metric is based, I cover the metric myself. The metric is based on 10, guys. It's very easy to use. You multiply or divide by 10. Everything. Unlike the inches and the 12 inches is a foot. But
I think Jeff was saying they tried, or no,
they tried
Mr.
many.
Flukem, they tried several times.
Yeah.
Just didn't
Some
take it.
government buildings will have to be designed based on a metric system. Didn't one of the, what do you call it, the shuttle went down because of conversion between metric and standard? Which one of them that went down? They said the major problem was conversion by engineers. They were mistaking. Yeah, it was in the 80s, I think.
Oh, yeah.
Yeah, yeah, they went down because of conversion factor between metric and standard. So, anyway, so in terms of prefixes, guys, I told you please pay attention to the mega, a million, and kilo, 1,000. These are a big deal when it comes to the power industry. Useful conversion without that. So that's basically it, guys, about this particular chapter. Any comments, any questions? Comments, questions about that? I'm going to give you 5 minutes and I'm going to walk you guys through this specification here, this blueprint. There's a couple of, in page, if you have it, page 12 and 13, guys, they have elevation, plan, and sections. The way they do the blocks, the architects, like this, all these symbols, you don't need to know that, but be aware of it. So if you see these symbols, you know that this is a block wall or shear rock wall. Why? Because if you want to penetrate right through it, you can penetrate 4-inch concrete is different than a sheet rock wall, right? It's gonna, when you estimate it. This is a big deal, guys, when you deal with it. Or if you want to mount something to a sheet rock wall, a transformer, you mount it to a sheet rock wall, you gotta be careful versus a block wall. Yeah, labor and hardware. Yeah, labor and hardware. You can't. So that's when you become a typically when you're an engineer and doing all the planning, that's a big deal. Knowing you need to know what type of construction. Are you doing block or are you doing concrete, steel, wood? So you can decide what type of wiring methods and what type of material. So, okay, let's take 5 minutes, guys, and we'll convene.
How come some of these symbols are similar, like steel and concrete block?
Let me see. Let's go over chapter 2, will you? Chapter 2 talks about the blueprints. Electrical working drawing. This is what you're looking at. So grab this. I used to have it electronically, and I have to admit that I left the CD at home. So I'm sorry, guys. Otherwise, I'll show them electronically. Okay, so this is what you're looking at, guys. The blueprints and the symbols that we use. So I'm going to walk you quickly through the first page. Can you please look at the first page that you have in front of you? It's first page should be A1. Can you see it, A1? In this building, we have 5 tenants. 5-tenant commercial building. If you guys have the blueprints, 5-tenant commercial building. We have those 5 tenants. They are a beauty salon. Am I saying it right? I always used to say a beauty saloon, and then they left. Yeah. I know. Everybody left. A beauty salon, bakery, insurance office, real estate office, so and drugstore. 1, 2, 3, 4, 5. 5 tenants in this building. If you guys look at the first page, page A1. A1 says basement floor. You guys know how to read the blueprints. It has a label. If you look at the bottom, commercial building, A1, out of sheet 1 of 10. Can you guys see what says sheet 1 of 10? A1 is a drawing. The basement floor, that's a, what's the scale? Everybody can see the scale? In the bottom right, the scale is 1/4 to 1. You guys, so that's how you read that one. Okay, moving on. If you guys look, you see all the dimensions. Who cares about this? This is architectural. That will give you the type. It looks like it's concrete, the building and block, and that will give you basically the dimension for every single area in the basement. Architectural. That's all what you need to know. You can see the bakery, beauty salon. You can see the drugstore, and you can see insurance office and owner area. Any comments, guys, about the basement? So there will be some questions to go ask you about the dimension of the owner room or certain dimension of the first floor. So or the area of the first floor. You take the width multiplied by the length, and you get the area. Okay, so this, and I don't know if you guys can see right in here, there's also the index of all the drawings. Drawing index, can you see A1 through A6, and then E1 through E4, everybody can see that? Okay, good. So that's all I want to talk about this one. Let's go to the second one, please. The second one is first floor. This building is 2-story with a basement. In the first floor, the bakery, we have a bakery store, and we have the bakery, the whole first floor. In the upper is a bakery and the drugstore. It's shared between a bakery and a drugstore, and you can see all the dimension of all the areas. And the scale is still 1/4. All right, moving into the second floor, which is A3. Are you guys following? Oh, you don't have that. Yeah, sorry. The second floor is A3. The scale is 1/4, and we have the beauty salon, we have the real estate office, room 1 and room 2, and we have the insurance company in the second floor. Remember, there are 5 tenants. 5 tenants. And they're giving you the dimension. The nice thing about the architectural guys, they give you a dimension of every single room in the area, the windows, the doors, and all this good stuff. So you can pick the information, the bathrooms and what's not. Moving all the way to sheet number A4. A4 have elevations. Can you guys see A4? A4 has a site plan, east and west elevation. So if you guys look at the upper left corner, can you guys see the upper left corner? Upper left corner, there is a site plan. Helen Boulevard, and they're giving you, why do we care about the site plan? That's where you guys, the upper left corner of A4. A4.
And you don't have anything, this is cut off.
That's weird.
Read one.
I have the prints from last year, it's the same.
Okay. Maybe if you search, if you see it, it might be in a different location. Yeah, maybe it's in a different location in the old book. I know it's a little bit different.
And he has that good color.
It flip it. I need one of these. All right, can you guys see the site? The site is 137.5 feet by 135, and it's kind of angled a little bit. That's where the building's going to be located. There's a parking lot, so that will give you the dimension of the site and where you're gonna. The site is so important, guys, because you bring the power to the building. You need to know where the power is coming to the building at low voltage. Right underneath it, there's west elevation. What would we use elevation? If you were to put a security light or exit lights, you need to know the height of the doors and the elevation. It becomes very handy. For example, please look at the elevation, the west elevation. You can see the main door there, and you can see a bunch of windows there. So that's basically, and give you a couple of other details. If you look at the upper right corner, there's east elevation. There's a door in the east elevation, the name of the building. Can you guys, in the upper right corner, in the left of the upper right corner, can you guys see where it says exterior lighting, where the fixture is located? Exterior lighting. Can you guys see that? It's actually on both sides. Exterior lighting. There's 2 lights. Exterior lights. They're putting them right there. In Revit, guys, when you drop, let me tell you what Revit does. When you put your stuff in Revit, you will be able to generate all this. The architects, when you finish your work and you send it to the architects, you should be able to generate everything that you're looking at from the model, including your lights. That's why it's so important to put your light in the right location. Imagine if this light, you show the elevation, it shows right through the door. The architects are not going to hire you next time. You know, if you know BIM, building information modeling, and you have to pay attention to the height. So when you put your fixtures, guys, first we drop it, and then we go look at it in the side view to see how it looks like in the side view. And I'll show you how to do this in Revit. Yes, sir.
Set in the properties for the different height.
Yes, you can set it on the property. Absolutely. Yep.
Do you drop everything on center? You know, like maybe 8.5 feet on center?
On center. Typically on center. On center. On center, it's easier because then you don't have to worry about how big the fixture is. On center. And you can see the dimension. If you guys go to A5, please. A5, have have north and south elevation. Can you guys see how the upper one is south elevation, no doors. There's an exterior light. Can you guys see two of them? They're sitting at the exterior light, the bottom of the exterior light, or um, finished second floor. Can you guys see where it says finished second floor elevation to 218.33? Oh, by the way, everybody knows how to measure the elevation by the sea level, right? So when you see, for example, you have to, I'm not sure if you guys know that. So if you look at the first floor, let's look at the first floor. First floor, I'm looking at the south elevation. The first floor is sitting at 208, maybe I should write here. First floor, can you guys see the first floor elevation is sitting at 208 feet. Second floor is sitting at 218.33. This is above the sea level. That's a low area, right? And then to find the difference between the two, you take the 218.13 and you subtract the 208 from it. So that would be, what is it, 10.13, almost 10 feet. In feet. 10.13 feet, the height between the height of the floor.
And that would be the bottom of the picture.
That will be from the bottom, that will be from the top, from the first floor to the bottom of the second floor. Second floor elevation. From the first floor, from the top of the first floor to the bottom of the second floor. So
The light sits at the second floor elevation, is that?
it's sitting at the bottom of the fixture is sitting. It looks like sitting at the second floor elevation. That's how we work. But can I, before I leave this one, everybody knows how to find the difference between the elevation. They always give it. The architects always give it to you guys in the sea level. You just subtract the two from each other. Okay, if you guys look at the north elevation, in the north elevation, you can see there's a basement, and we have rear yard elevation is 206, and there's gutters, and there's a blocks, there's some two lights there, there's brick vents there, and a bunch of other things. Line of roof, and it's really, we don't need to be architects, guys, but we need to understand a few things so we can pick our own electrical stuff from it. So that's basically the two-story building with an elevator that you look with a two-story building with a basement that you're looking at. Some of the questions, guys, on this chapter will be referring you to these. So get you what's the elevation of the first floor, the second floor, whatever, what's the dimension of the room. So please refer to these. That's kind of exercise of getting into knowing the material. Okay, moving. Any question before we move into that? Give you. Okay, moving to A6. A6 is in the architectural world, guys. You haven't done architectural, right? In the architectural world, when you draw a building, gentlemen, there are views or plan view. You have the plan view, and then you have views of a building, right? So here's my let's just say here's my building, right? Here's my building. When you draw a building, you have views. The top view always is called the plan view. That's what we put our stuff on. That's the top view. Then you have the side views. This side, this side, this side, and this side. So that will be, for me, it will be front, the rear, the right, and the left. Or in this case, it will be the north, the south, the west, and the east views of this building. They don't do the bottom. You could probably look at the bottom here. The top view is always the plan view. Everybody understand that one? That's called the top view. Okay. Now, in addition to these 1, 2, 3, 4 views plus the top view, which is the plan view, in addition to these 5 views, they also have sometimes 3D view. 3D view, when you look at the building in 3D, you can rotate it. That's 3D view. Okay. In addition to the 3D view, they have also sections. They call it sections. The sections, guys, is they cut the building into half right here. Cut it. Saw the building and take one section out and look and draw what you can see. Why do they do it this way? If you're looking from the west here, do you think you can see the hallway here? You can't see the hallway. In order to see the hallway, imagine a big saw, and you saw done with it right from the middle where the hallway is, then all the way down to the first floor. Then you can see all the hallways. Then you can draw them. You can do this in Revit easily, guys. You can put a section view in Revit anywhere you want, and you're going to be using this called section view. You drop a section view. I want to see the hallway. You drop a section view from that corner all the way to here. The minute that you finish it, it will draw a section view of the hallway. So easy in Revit, so easy. Any view you can section view. It's called section view. Okay, so there are two section views. Section AA, and AA, guys, is coming from where did they put AA? It's coming from these two sections. They show them right here. Okay, if you do go page 1, please. If you guys go to page 1. A1, yes. I'm sorry, page 1, A1. I should say A1. Page A1, right in the middle of it. Can you guys see that little arrow that says A on it? The section right here. Can you guys see that little A and underneath the A6? This is section A, and it's drawn in A6. This is section A drawn in A6. That's how Revit does that too. When you guys create a section, it gives you a number of sections, the section 1, and underneath it, the drawing where the section is drawn. Very common. And what they do, can you guys see what section A cuts right across? So it comes from here, saw the building this way. Section B right underneath it, can you guys see that? It saws the building vertical. So it saws it right here. Here's the end of section. So you can see the beginning of the section and the end of the section here. The beginning of the B section and the end of the B section. Can you guys see that? Everybody can see that? So, makes sense? Okay. That's how they saw the building. Vertical, horizontal. And they want to see vertical and horizontal.
Kind of like the arrow built in that circle.
The arrow, yeah, with the arrow points, yes, the arrow points, okay, I'm going to saw this building. I'm going to saw it this way. The arrow points to where you're going to be looking. If I'm going to be looking this way, the arrow will point this way. Look what? If I'm going to look that way, this way, then the arrow will point. If I'm going to stand right here and look at it this way, then the arrow will be pointing that way. Because that's what's going to be drawn. That's what you will draw. Where the arrow is pointing. Okay, everybody understand where the arrow is? Guys, Brandon, my friend, in Revit, the arrow is so important because you guys will be draw sections in Revit. And say, Chad, I can't see what you want me to see because your arrow is pointing the other way. You should, and in Revit, look how nice, you know what Revit does? So easy. You can flip the arrow. You click on the arrow, it was pointing this way, now point the other way. You see this way now, or this way. So Revit, I tell you, Revit replaced every 10 architects now. They used to do the job they used to need 10 architects, now need 1 architect because of Revit. Unreal. So, okay, so we saw the section. Let's go back to A6, please. So when you go to A6, AA is the horizontal section, and you can see what, now they showed it, now you can see the stairway. Can you see the stairway? It shows you the stairway, the interior of the building is shown. That's the reason why they have sections, because it shows you the interior of the building. If you look at a section BP, it shows you the vertical section and also the interior of the building. Can you guys see that? Now it shows you the stairway and a bunch of other things. Believe it or not, this is so important for people who build the building units. Very important. It gives you a view of what's inside the building, so you can build it. For us, it's so important, for example, because it shows you the height, interior information. For example, if you guys look at the section BB, the bakery store, from the floor into the structural ceiling, the height is 9 feet. Can you guys see that? It gives you the actual height. So here's your fixture, for example, right here. From the floor into the structural ceiling, 9 feet. So if you want to mount your fixtures, you can't mount it up, so you have to take it, it looks like 1 foot here, so you mount your fixtures. So 10 feet, the top one, here's an 8.6. It looks like there's a suspended ceiling. Can you guys see? There's a suspended ceiling right here, and it's sitting at 8.6. Now, what would that tell you? If your ceiling suspended like 8.6, when you mount your fixtures, gentlemen, you will mount it at what? If they're recessed, 8.6. So that's what's so important, guys, in Revit. When you drop your fixtures, in Revit it's easy because they immediately host to the grid. So, but sometimes you put them outdoor, you have to pay attention to the height. What's the height? Okay, any comments, guys, about the sections? Any comments, gentlemen, about the sections of these?
What, I guess, I don't know if you said it already, but what did those arrows with the A and the A6, what does it mean?
These are sections. That means you cut the building, the AA cut the building this way if you look at it. You cut it and you're looking at it.
Oh, I'm saying, so this section isn't displayed on this one, and then saying it's on A6.
Yes, so section A, they have, if you look at an A1, it shows you where section A is located. What are you cutting? So it just shows you a line that says, here's where section A is going to be sitting, and here's where section B is going to be sitting. Then that's where they are sitting. But where are they drawn? Right underneath it, we say A, it's A6. So A is the section number. A6 is where the section number A or letter A is drawn. So Revit, I believe, does numbers there. So they you'll do section 1, and underneath it E5. So section 1 is drawn is E5. Yes, sir.
For 4-2 on the top section.
Where are you in the cross section?
One of them says it's 8-3 on AA, and the other one says it's 10-4.
They must have different. But remember, you're looking at it differently. So is it the bakery?
The same, right?
No. Well, one of them is drugstore and the other is a bakery. 10-4 is a bakery. Look at that.
Oh,
And the other one is drugstore. So do different. I know, guys. It depends where you're cutting it. So there are two different locations. Yeah. There are two different locations inside the building. I know imagine your terminal when they have all these sections and all these terminals. The more complicated building is, the more section you have to do. With Revit now, you can walk the people through 3D of that design. That's why we have a discipline called architects. And those are the guys who keep track of it. For us guys, we're supposed to just understand it enough so we don't get confused with our electrical system. The details, you have a whole discipline that are responsible for getting all the ins and outs. And if you're confused like you did, Brandon, the first thing you do, confused with certain dimension, you pick up the plan called the architect. Because that's what they spend hours and hours, guys, putting these things together. With Revit, really, now they build the building and they just put the sheet, the cross section. Okay, any comments, guys, about these? So the first 6 sections are architectural. Why do we list them? Because it tells you the type of the material that we're going to be constructing from. And I believe they're using, it's a commercial building. Typically a commercial building is, most of the buildings, either steel building or concrete or block buildings, commercial buildings, right? Some commercial buildings are wood buildings too. So you need to know if it's wood. This looks like it's a steel and concrete building. So concrete foundation and steel studs in between. Why it's important? Because if it's steel studs and depending on the wiring, typically we use MC cable. The wiring method that we use is MC cable versus an M cable. You know, I don't think of any engineering work where you use other than MC cable. Yes, MC cable is the cable of choice for all commercial building. So you will learn that one as you go through. Okay, let's go guys to E1, please. I'm not going to go into details in E1. E1 shows you this is the basement electrical plan. We'll go over these now. Remember, the book, guys, follow these in details. It follows these plans, so there will be a chapter that talks about lighting in this area. So I'm not going to talk too much about it. I just want you to pay attention to the following. Can you guys see the arrow? The arrow will point toward, so in the upper right corner, you guys see water heater with a disconnect? Upper right corner, okay. It says the home run on it is BS, stands for Beauty Salon. Beauty Salon, can you see that? BS is Beauty Salon, and 12-16. 12-16 is circuit 12 and circuit 12, 14, 16. So there are 4 circuits, 3-phase. It's 3-phase, 4 slots. It's a 4-slot circuit breaker for this circuit. You guys following? So 12, 14, so it looks like, there you go. So here's my disconnect, here's my water heater. It's a 3-phase water heater. Here's my home run. My home run says, what do you say again? It's SB, BS. BS, it says, let me use a different one. It says BS 1216. 1216. Here's what 1216. It means it needs a circuit breaker, a three-phase circuit breaker that's going to take 3 slots. So slot 1, slot 2, slot 3. This slot is 12, this is 14, this is 16. The way they make the panels, guys, look at this here. The way they make the panels here, they're labeled from top to bottom. From top to bottom, there's 1, 2, from right to left, 1, 2, 3, 4, 5, 6, 7, 8. They go from right to left. When they label the panels, you can see this one later on coming. Right here, here's my panel. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All panels, 3-phase and single-phase, are labeled this way. Odd on the right, even on the left. So the circuit, these 4, 3 are going to be going to where? This guy. Does that make sense? Does that make sense? It will tell you it's a 3-phase circuit breaker. If it was a single-phase circuit breaker, what would it show? It will show only BS12, single phase. If it's a 2-phase, not 2-phase, 2 hots, what would it say? 12, 14, 12-14, right? Only 2. If it's 1, it will say 12. So if it needs 1 hot, 12. If it needs 2 hots, 12, 14. If it needs 3 hots, 3-phase, will say 12 through 16. Any comments, guys, questions about the circuiting? That's how they show the circuiting. Yes, sir.
Why is it that they start on the right side?
Oh boy, this question, you know what? Our hammer is coming when the manufacturers. I think it's industry standard, but how did it start? I don't know what the start is.
They're made in Japan.
Yeah. Why not in the left? 1, 2.
Yeah.
Yeah. Well, I grew up reading from right to left. To me, it's normal, but so I wonder if it's good.
One of the few countries that reach from.
Yeah.
No, I know.
Hebrew and Arabic are read in Hebrew and Arabic to read from right to left. So to me, it looks normal probably, but I hear you. I don't know what the. I really don't know.
Switches to a dominant right-hand country, so
Yeah.
they don't
But
steer.
we have color hammer or Google it, guys. Once you Google it.
I get all that.
Why not 1, 2 this way? Yeah, I never thought
They're
about
having
this.
some are made here, you know, so.
I would just say, it's like, would it be?
Anyway, gentlemen.
Oh, yeah.
Okay, I don't want to walk you guys through all of them. I want to point one more. If you guys look in the upper right corner, also BS3 is feeding receptacle. Can you guys see that? BS is a panel, 3 is a circuit. BS is a panel, 3S is circuit. Okay, so you can see lights and receptacles. We will go over these in details. Let's go to E2. E2 will refer you guys to the first floor power. Can you guys see there are multiple lights? And we will be talking about these guys again in details as we move on. Pay attention to the fixtures have a letter inside them. This is that fixture type. The letter inside the fixtures is a fixture type. I think, I'm not sure. Oh, okay, so all these are yours. Go all the way to E3, guys, same thing. This is second floor. And again, we will get into these in details, guys, as we move on. So you have your receptacles and power and lighting, everything. What they did here for this project, they did the light and receptacle in one sheet and the low voltage. Our project will be separate. We will have one sheet for light, one sheet for receptacles and power, and one sheet for low voltage. You guys understand? So 3 sheets. No, can you put them all in one? Yes. All right. So again, we will go into these details. The last one I would like you to look at is the last sheet, Z4. E4. E4, gentlemen, has 5 schedules. I would like you guys starting from the left, upper left corner. If you look at the panel bakery, can you guys see the bakery panel? It's the voltage is 28123 phase 4 wire. It's located wall near back door. The amp is 40 amp lugs. What does lugs mean? No sir, no main. This guy, do you guys see a main like this? Do you see any main here? No. That's a lug only. You can see main lugs only or main circuit breaker. Very, very important. In Revit, when we drop a panel, it will say main logs only or main circuit breaker. So when they ask, when do you use a main logs and when do you use main circuit breaker, I will go over this later. The second panel, guys, is the drugstore. The third one, from the second from the right, is insurance office, then beauty salon, and then the owner. Can you see where the owner is? Owner, all of them are 123 phase, and real estate office, and there's some are 100, 200, 200, 200, 200, and 400, the amps. Make sense? These are all, they call the panel schedule. From right, I'm going to go to the upper right, to upper left corner, bakery. I would like you guys to look at circuit number 1. What is circuit number 1 feeding, please? Thank you. And there's no one to read that. Okay, let's go to circuit number circuit number 27, 29, and 31. Is this a 3-phase or single phase?
3.
How do you know?
3.
3 circuit breakers or 3 slots. They call it 3 slots.
Slots.
Okay. Okay. So how about circuit 41? What is circuit 41 feeding?
Spare.
Spare. Open. Okay, go. The reason why I would like you guys to look at these, because you're going to be generating this in Revit. All this is going to be generated in Revit. Very simple. I'm going to take you to one that says, okay, go to the beauty salon, will you? Could you please go to the beauty salon and look at circuit 11 and 13 and tell me what's 11 and 13 feeding? Can somebody tell me what's the voltage on this gentleman? What's the voltage on the washer and dryer? There are 2 circuits going to it. Washer and dryer. What, 30 amp washer and dryer. It's 208. Single phase or 3 phase? Single phase. It's 2 hots. Remember, 2 hots. When you have 2 slots, 2 hots. 1 slot, 1 hot, and a neutral. 208. Yeah. 208. 1 slot, 120.
2 or more, 208.
2 or more, 208. Yeah. And we'll go over this also guys in details. If you go to the upper right corner, please. Service equipment. This is how they're going to do the service, guys. They're bringing a service panel. That's your service panel, upper right corner. It says service 3R, enclosure service 3R. 3R rated for outside door. The voltage 208, 120. They have the interrupting rating. Look at the circuit. Circuit number 1 is going to the beauty salon. These are the main panel. This is the main panel. Circuit number 2 going to the bakery, all the way to circuit number 6 is going to the owner. So there are 6 circuits in this panel, and they're all going to different locations, right? Can you see that? Different locations. All right, right underneath it, there's a one-line diagram. You guys see that one-line diagram right underneath it? Start from the left, please, with me, and I want to walk you through this in details. Do you see the transformer?
Yep.
That's Excel or utility transformer. Bring the wire. You bring the wire into what looks like termination box, of like a gutter. And you're bringing the cables. Can you guys see they're tabbing them? Okay, you see the amps? What does the amp stand for? Meter. So how many meters do we have?
6.
1, 2, 3, 4, 5, 6 meters. Can you see them? So we go through the meter, and then they have a fuse disconnect. If you look at the beauty salon, the top, the upper left, it says 200 amp. The first 200 amp is for the disconnect. The second 200 amp is for the fuse. 200 amp disconnect, 200 amp fuse. Going to the beauty salon. Okay, go look at the bakery. Tell me what's the disconnect size on the bakery.
400.
What's the fuse size?
300.
You got it. So that's how they get it. Now, they're all main lugs only. You guys know why they are main lugs only? Because they don't need a circuit breaker. Why? Because they already have a fuse ahead of the cable. That's why they are main lugs only. Like for this guy here, it's a main lugs only. No main circuit breaker. Why? They don't need it. Why? Because the circuit breaker that protects this panel is done with his business.
So I'm starting to understand why, like, if I wanted to turn that, I want to throw the main though.
You have to go down to the base.
Go down.
Now, if you want to, there's nothing says that you can't put them in here. You can put them in here, but what?
It's the money.
the money. You added another $100 if you put them in. Now imagine 100 panels like here, and you can see it adds up. That's why they don't put them in. If you have a circuit breaker ahead of it. Yes, sir.
For the real estate panel, if this says 100 amps, there's no lugs, what does that mean?
Real estate office,
Yeah, because the owner is 200 lugs, and the real estate just is 100.
100 amp, it must be a circuit. Are you looking at the panel?
Yeah, the panel.
The owner, right? The owner, 200.
Real estate office.
Oh, the real estate office. The real estate office says 100.
Yeah, it doesn't say lugs or anything else.
It's a mistake. So let's look at the riser and see how it's real estate office. No, it's main lugs. It should be lugs. That's a mistake. Should be lugs. Good point. Why don't you, if you email the owner, the author of the book, he might get you a copy free, man.
Probably not.
You can name it. Where's using that? I'm not seeing that.
Oh, you didn't have to. Underneath the amps.
So the 6th panel,
The 6th panel, the real estate office, where it says M right in the center of that here.
Yeah, there was an X.
Yeah, it doesn't say LUG. It logs on the.
Yeah, but I'm not seeing lots of anything right here.
Look at the 200. Look at the one above it. 200 amps says lugs underneath it. Look at all of them where it says the amps. You see where?
Yeah, I see.
Yeah.
400 amps, 200.
Yeah.
I don't know what.
Oh, what did you guys?
I have the whole book.
Oh, okay.
Now,
Now that's.
you guys all seen this book?
I'm sorry. Okay. Okay, I'm sorry. Come on.
None of my.
That's. You guys have the lugs in yours? No?
You guys.
Oh, sorry, bud.
No, that's right.
That's what.
That's what I'm saying. Where you guys seen the ones?
Okay.
It doesn't matter.
Okay, so if you guys look at the meters, and then do me a favor, go look at the generator. Can you guys see on the right side of the riser? One line diagram, there's a generator. You see it? It's feeding an auto transfer switch, right? You see where it's a little gen? And the right side of the one line diagram, right here. Yeah, it's feeding an owner equipment, and one of them is feeding elevator control, and the other one is equipment, elevator equipment. This is for your emergency. So they have a generator required. If you have an elevator, you're required to back it up with, as well as an emergency light. So they're backing up their generator, their equipment, elevator control dash jack. You don't have to.
The loss of power automatically.
Yes.
Goes to the,
A loss of power, start the generator, picks up, and your elevator is up and running.
and then once power returns automatically.
Once power returns, it shifts you back into the power.
So once power goes, it switches over.
Yes, within 10 seconds.
Relay, right?
Other kind of
Yep.
things.
They're sensors, they sense the voltage. When the voltage is lost, they go start the generator. The generator is typically, guys, what they do, they keep the generator hot because they have a heater. They keep the generator hot. So it's like your car, they keep it hot. So the diesel engine generator, so because it's kept hot through a heater, the jacket heater, send the signal instantly, the generator start, and within 10 seconds picks up the load. When the power comes back, the gen will wait for 15 minutes. Typically, there's a delay. So the power comes back. For 15 minutes, you monitor the power. Is it stable? 1 minute, 2 minutes. Count to 15 minutes. After 15 minutes, yeah, it's stable. Go back to that rate. They don't shift you immediately. It's smart because when you have a storm, sometimes it comes and goes immediately, right?
Yeah.
So you don't want the generator to be turning on and off all the time.
So the generator is only controlling the elevator.
In this case, it's feeding it looks like an elevator. Yeah.
There's no emergency lights on.
Their emergency lights, I believe, they're bug lights. They're battery. You can have emergency lights two ways, guys. You can have emergency lights on generator, or you can have emergency lights on batteries. Generator is expensive. So what looks like in this project, they're doing the generator only for the elevator. Their lights are battery lights. Okay, so that's basically what this. I'll walk you guys through this one in details as we go through. We talked about all these. There's a couple of things. If you guys do me a favor, go to page. Please go to. This is page 45 in the new book. There's something called neutral point. Can you guys see the neutral point and ungrounded conductor? So I'm just going to draw a three-phase, and you guys will be. This is my neutral,
my phase A, phase B, phase C. This point, can you guys see this point? This is called the neutral point because it's a coming point. The voltage between this point and any one of these phases is the same. So this is a 208/120 volt system. And the conductor that's connected to the neutral point is called the neutral conductor. The phase A, B, and C, the code called them ungrounded conductor. They're ungrounded conductor. The neutral conductor is also called grounded conductor because we tie it to the ground. How do they tie it to the ground? We'll talk about this later. They grab this and they tie it to the ground. Can you guys see that? It's tied through a ground rod to the ground. The neutral only. The grounded is the neutral and it's tied to the ground. The ungrounded is the phase. Phase A, phase B, phase C. What else do we? And they have a list of different ways, guys. There's single phase. Can you guys see in page 45? From the upper left corner, there's single phase one. There's the one that I drew here. There's also center tab. There's a delta, grounded. There's zigzag one. Can you guys see the bottom that has a little, they call it zigzag transformer? And there's a delta grounded, and there's a single phase. So there's multiple ways of grounding it. And I'll talk about grounding in details, guys. This is just a quick intro. So phase A, B, and C. This is this one, and the neutral obviously is the neutral. We love the ground so much. We identify everything by ground. So talked about the drugstore, guys. This is just going through all the material that we did, the bakery and all this good stuff. So this chapter is really walking you basically through the presentation. Okay, one more thing I would like you guys to go. Symbols. I don't have, unfortunately, I do have them, guys, but I left my CD at home, so I have to admit. Let's go, please, to page, go to page 37. There's a raceway symbol in page 37. Preferred symbol and description. Can you guys see how they do in page 37? You see where it says a line? The line means conduit concealed in finished area, exposed in unfinished area. That's how that's some of the ANSI symbols they use for conduit. Right underneath it, dashed line, conduit concealed in or under a floor slab. These are the symbols, guys, that they use for conduits. You know, look at the last, I'm not going to read all of them. The last one, it says UCD, underground flat conductor cable, FCC wiring system data. So that's the symbols that we use. You don't have to memorize all these. Typically, they are in the symbols I gave you guys. So just be aware, if you see a symbol, electrical symbols, make sure you go check what the answer, what they refer to. Page 38, please. Page 38, raceway indication symbols. Look at the first one. Preferred symbol. Can you guys see that symbol? And conduit stop. Conduit stop terminal with bushing or cap if underground. Look at the one right underneath it with the circle. Conduit turning up. Look at the one with the dot. With the dot. Can you see that one? This conduit turning down. These are how they show on the symbol. If it's black dot, it's pointing down, going down. Because in 2D you can see that. If it's that little opening circle, it's going up. So when you guys are looking at the blueprint, make sure you look at these. Look at the home runs, how they show the home runs. All right, in page 39, my friends, luminaire lighting fixture schedule. Here's the symbol that they use for fixture schedule. I would like you guys to look at this one. This one, it says emergency battery unit with luminaire heads. So when they ask you where are the emergency lights in the building, make sure you look here. This is the symbol that they use it. Typical. You guys are going to be using it in Revit too. Wherever you see the symbol, that will be the, they call it bug guys. You know, the bug guys that are going right through the building. And the rest of them are all these symbols. This one, for example, is luminaire strip type linked down to scale. Right next to them also luminaire lighting schedule. Here's surface mounted fixture. Look at the symbols that they use for it. So this is their symbol, guys. I will walk you through the symbols I will be using in Revit. You'll see them. But these are the symbols that they're using to design this project. What's in it for you? Look at them, educate yourself about them, so familiarize yourself with some of them. They're similar to the stuff that we're going to be using in the 2 projects, or 3 projects. Okay, moving all the way, guys, to page 40.
Same thing, receptacles. Look at this one, floor duplex receptacle. The first one, this is simple, this is the floor. The last one right here is a double duplex receptacle, ceiling mounted. Can you see that? So that's a symbol they use, double duplex receptacle, ceiling mounted. So, and bunch of others in between them.
So something like this installed when the building was built, or was kind of just put in afterwards?
Which one? The surface mounted?
This whole.
Surface mounted, yeah.
After.
That would be the multi-outlet?
That will be the multi-out assembly devices and absolutely. This guy here, this guy will be the assembly part. Multi-out assembly. Absolutely.
If you guys look at page 41, switches, look at all the symbols, the dollars.
Are you the one who asked me about the dollar? The dollar
Yeah.
sign? The dollar sign or S. There are two ways. Either you put S or dollar sign. So either single pole switch, you're looking at them right there, the same single pole switch is there. And then right underneath, if you put 3, that will be a 3-way switch. If you put 2, double pole switch. You guys know what a pole is? If it's switching 2 phases, it's double pole. 3 phases, triple pole, 3 pole, single phase, single pole. A pole is a phase, typically. If they put S4 next to it, these are not 4 poles, these are 4-way switch. 4-way switch. It always confuses people. If you put, for example, DT, SDT, this is circuit, single pole, double throw switch. Single pole, double throw. Anybody knows what single pole, double throw? Single pole, double throw. If you flip it this way, it connects to one circuit. If you flip it the other way, it connects to a different area. Single pole, single. You guys use them with use them with don't you use them with the PLC? So single pole, single throw. Here's single pole, single throw. Double pole, double throw. Here's a double pole, double throw. A single pole, double throw. This way, goes either way. Double pole, double throw. Double pole, single throw is double pole, single throw is like this, and then double pole, double throw is like this, and then you keep going poles here and throws here. It gets out of control. Imagine 3 pole, 3 throw. I don't know if you do it. 3 pole, 2 throw. 3 pole, double throw. That's the auto transfer switch. They call it. When you have an auto transfer switch, you have 3 pole, and you drop each one of them to one side or the other side. So the poles in the throw. Yes, 3 on the one, 6 on the other side. Why 6? Because 3 coming from the normal and 3 coming from the emergency. Anyway, it gets interesting. So these are all your switches, gentlemen.
Keep moving, guys. I'm going to go to page 42.
These are your disconnects. If you look at if you have an XXA disconnect, this is disconnect switch, unfused type, size as indicated on the drawing. XX indicate amp rating. So when you say 100 amp, right next to the disconnect, that's a disconnect size. If you put an F in it, can you just see if you put an F, it becomes what? It has 2 sizes there. One for the disconnect and one for the fuse. Can you put a 40 amp fuse in a 100 amp disconnect? No. The disconnect must match the fuse or be bigger. Because you have to fit the fuse in the disconnect, so it has to be at least the same size. Anyway, there's thermostat, relay, all this good stuff. You guys read through them. Limit switches, LS, and so forth. On page 43, my friends, we have motorized and HVAC equipment symbols, and and next to them the distribution equipment. I want to focus on this panel, guys, right here. Lighting or panel power on a normal generator, normal set generator feeder. That's how they do it. If you have distribution panel on normal or generator feeder, this is how it looks like. If you see them different in our project, don't sweat it too hard. Sometimes symbols, guys, differ from company to company slightly. So every time you have a project, your working project, always look at the symbol list that you guys are using. That's what you're supposed to match. Anyway, so we have panels and what's not. And the last thing in terms of symbols, my friend, is in page 44, site work. When you're doing the site work, can you see it right here in page 44? If you have a dashed line with you up on it, what do you guys think would that be? underground feeder. If you have a UT, underground telephone, UFA, underground fire alarm. If you have UTV, TV. If you have that simple with MH, manhole, handhole. You guys familiar with manhole? Manhole, a man can get in. Handhole, only your hand can get in. Conduit, prefabrication, manholes, and what's not. So these are the symbols that you use on. Gentlemen, that's basically it in this chapter. Look at the blueprints, please, verifying it. What's in it for you guys? I know a lot of information, but you know, nice colored books, familiarize yourself. You don't have to memorize everything. Read through them, kind of get used to seeing these symbols that we'll be using, especially the electrical ones. Cool? Any question for Chad, my friends? So one more sample for you, one more project, basically. Okay, thank you guys. What we're gonna do, let's do start at like 10 like we did last time, and we do Revit after that. Give you enough time to recoup a little bit. And then shall we continue with Revit?
Are they supposed to have one now?
Yeah, it said in 20 minutes, like about an hour ago.
Looks like that's in line.
She's been calling me like today, like 2 minutes.
But you're talking about the commercial and residential ones?
Yeah.
And then we need that step to step lighting or something, you know, step back or like. Did she say she was gonna have that one now, or is it just?
I think I saw residential ones on the shelf. We can do a syllabus quiz for communication.
What's that? No, you want us? I've never done fancy stuff. Yep. No, I